Okay, the last section that we're going to cover in Chapter 11, the last type of angle, is an angle that's on the outside of a circle. But let's just recap the ones we've talked about so far. Now, of course, there were central angles. A central angle was an angle that had its vertex at the center of the circle. That's where it gets its name. And the measure of a central angle was equal to the measure of its arc. Then we had what were called inscribed angles. An inscribed angle is also sometimes called an on angle. And that's because the vertex is right on the circle. And for an on angle, the angle is equal to half of the arc. And then in the section we just covered, that was the section where we had angles formed by two chords. So an angle formed by two chords is sometimes called an inside angle because the vertex is on the inside. And recall that the inside angle, the one formed by two chords, was equal to half the sum of the arcs. Well, there's only one other possibility. The only other possibility is that the angle associated with the circle is on the outside. The outside angles are formed by either two secants, as we see here, both of these are secants, or two tangents, we'll have a few of those, or a secant and a tangent. In any of those situations, we're going to get an angle that's on the outside. And when you have an angle on the outside, the angle is equal to half the difference of the arcs. Now, of course, difference means we're going to subtract this time. And we always subtract big arc minus small arc. So here's a quick reference guide for the angles associated with circles. We have, of course, the central angle, the first one that we talked about. A central angle is just, its vertex is at the center, and it's equal to the arc. The measure of the angle equals the measure of the arc. Okay? Then we talked about an inscribed angle. The inscribed angles are also sometimes called the on angles. And an on angle where the vertex is right on the circle, that's equal to half of the arc. And then in the section just prior to this one, where we had two chords that crossed in a circle, that was called an inside angle because the vertex is on the inside, and an inside angle is equal to half the sum of the arcs. And sum means to add the arcs. And then the last type that we're going to talk about today is the outside angles. The outside angles can be formed by a variety of things. Two secants, two tangents, or a secant mixed with a tangent. And when you have that outside angle, then the measure of the angle is equal to half the difference of the arcs. And difference means to subtract. Okay? Hey, thank you. So let's take a look at a few examples here. Again, these are the three possibilities. We could have a secant and a tangent. We could have two tangents or we could have two secants, but they're all handled exactly the same way. So when you look at example 1 here, example 1, we actually have a tangent up here and we have a secant right here. So that is one of these outside angles. And when you have an outside angle, the angle is equal to half the difference of the arcs. So we have to take the angle, and that's going to go by itself over here, and then 1/2. And then we have to take the big arc, so the 178, and we subtract the small arc. And you always take big minus small, or else you're going to end up with a negative number. And of course, we can't have negative angles. When we work that out, 178 minus 76, I get 1/2 times 102. So x would be 51. Outside angles equals half the difference, meaning subtract big arc minus small arc. Let's look at another example. Example 2. Now, in example 2, it looks like we have a secant. This one would be a secant. And this is another secant. It's still an outside angle because it's outside of the circle. So the angle is going to be equal to half the difference of the arcs. The angle goes by itself equals half the big arc, which is x, minus the small arc, which is 44. Now, just as we've seen before, if we have the variable in the parentheses, what I would strongly encourage you to do is to multiply both sides by 2. When we do that, we'd have 60 on this side, but more importantly, that cancels the fraction, and we just have x minus 44. And then we just add the 44 to both sides. We get 104. Okay, let's try another. Now this time we have two tangents. This is a tangent. It touches just once. And the bottom one is also a tangent. And they didn't give us both of the arcs. They didn't give us this arc right over here. But we do know a full circle equals 360 degrees. So that means this part right here is going to be 360 minus x. And we know the angle is equal to half the difference of the arcs. Now we always have to take big arc minus small arc. So let's set it up. The angle is the 30. That's the angle. The big arc is the x. And then the small arc is the 360 minus x. Now those parentheses are important. And the reason those parentheses are important is we have to remember to distribute this negative sign. So we have 30 equals 1/2, and then x minus 360 and a plus x. We combine like terms. 30 equals 1/2, and then 2x minus 360. And again, I would strongly encourage you to consider multiplying by 2. If I multiply by 2 here, I get 60 equals, and then 2x minus 360. Add 360, I get 420. equals 2x. Divide by 2, I get 210. So a little bit more complicated problem, but definitely something you're capable of doing. Okay, here's a practice one. We have 2 secants. So that means we have an outside angle. When it's an outside angle, the angle is equal to half the difference of the arcs. So the angle is the x. The big arc is the 88. The small arc is the 28. Okay, so what we're going to do then is we're going to work that out. X would equal 1/2, and that's really just 60. So x would be 30. Another practice one. Now in this practice one, we have 2 tangents, but they didn't give us this arc out here. That's okay. We can represent that arc. That's going to be 360 full circle minus x. And that's going to be the big arc. This one is the small arc. And this is the angle. So I'm going to have 50 equals 1/2, and then 360 minus x minus the x. Here we have big, here we have small. Combining the like terms, 50 equals 1/2, 360 minus 2x, multiplying by 2 on both sides. 100 equals 360 minus 2x. Subtract 360, I get negative 260 equals negative 2x. Divide by 2, x equals 130. The last practice one we have here. This last practice one, this is the angle. This is the big arc. And this is the small arc. So when we set it up, we'll have x plus 2.5 equals 1/2 4x plus 5 minus 50. Again, this was the angle. This was the big. And this was the small. So we have x plus 2.5 equals 1/2 4x minus 45 when we combine like terms. I'm going to multiply by 2. I distribute 2x plus 5 equals 4x minus 45. Subtract 2x. Add 45. And divide by 2.